could write this as, minus a half x and a minus 2 is completely up to you. You might ask about the integration constant here. You don't need to worry about it because essentially just will end up cancelling out, but it is a sort of genuine concern if you're thinking about that. So like I said, I'm going to calculate the indefinite integral first. So what I'm going to write down is, the integral of the natural log of x over x cubed dx, and then I'm just going to apply the formula. Okay, so it's u times v, so that's minus the natural log of x over 2x squared, so minus natural log of x over 2x squared, and then minus the integral of v du by dx, but notice my v is going to have a negative in, so I'm going to factor that out, and I'd always just recommend doing this just to watch out for those double negatives. So I'm going to actually have a plus here, the integral, right, and then v du by dx would have already taken account to this negative here, so we have 1 over 2x squared times 1 over x, that's 1 over 2x cubed dx, right? Pretty much already done this integral going from here to here already, so this is going to be minus the natural log of x over 2x squared, and then minus 1 over 4 x squared. Now, because we're calculating the, indefinite integral here to sort of use to then calculate the definite integral, we're just going to ignore this, right? Because this is going to cancel out when we actually evaluate this at limit points, right? I have plus c and then minus c will cancel out, okay? So now I know what my indefinite integral is. This tells me that my definite integral from 1 to 2, the natural log of x over x cubed dx, that is just this thing evaluated between those limit points. And actually what I should have done as maybe sort of an aside point over here is just tidy this up a little bit. It's very easy to combine this into one fraction, which makes life easier when you're evaluating this at the limits. You think we can just multiply top and bottom here by 2 and then factor out a minus sign. So we have minus 2 times the natural log of x plus 1 over 4 x squared, right? It just makes life a little bit easier. So this integral here is exactly just this expression evaluated at the limit points. And so we can go ahead and do this. So, when x is equal to 2, what do we have? Well, we have, our minus 2 times the natural log of 2 minus 1, right? Remember there's a minus here, over, well, 4 lots of 2 squared is 16. And then I'm subtracting from this, well, the natural log of 1 is just 0, so I have a minus, minus 1, so I've got to be careful. This, ends up being a plus 1, so plus 1 over, and then, when x is 1 here, we just have 4. So we can simplify this, right? This is 4 over 16, so this comes out to be minus 2 times the natural log of 2, and then we have minus 1. We've written this as 4 over 16, so this is minus 1 plus 4 over 16. And we can also note that we can rewrite this natural log of 2 as, using our laws of logs, right? This is just the natural log of 4, right? Bringing this into the power here. So overall, tidying everything up, what do we have? We have minus 1 plus 4, so 3, minus the natural log of 4,